Hello students, let us take some MCQs not belonging to a particular type, so the name miscellaneous MCQs. Let's see the very first in this case. They want us to evaluate the integral cos of 2 times tan inverse root of 1 minus x upon 1 plus x dx. The function given to us is such a big function there. Options are very small. Let's see how to solve this. I don't want to go into directly solving the integral, so let us consider cos of 2 times tan inverse root of 1 minus x upon 1 plus x. Now my dear students, if at all I need to integrate this, first I'll see how to simplify this particular term here. In that also, first we'll try to simplify the function inside the tan inverse. Now if I recall, function in the tan inverse looks like root of a minus x upon a plus x, correct? If I compare, I can say in this case we will have a as 1, and for such type of square roots we use the substitution x is a cos theta. Here in this case a is 1, so in this case what we will substitute, x is cos theta. So now if this is the substitution, what will my function look like? We have cos of 2 times tan inverse root of 1 minus x upon 1 plus x. So this will become cos of 2 times tan inverse under root of 1 minus cos theta upon 1 plus cos theta. Correct? Now what we will do further is apply the formula of 1 minus cos theta, which is nothing but 2 sin square theta by 2, and that of 1 plus cos theta is nothing but 2 cos square theta by 2. The 2 inside the square root will get cancelled. What we will get is under root of tan square theta by 2. So let's write that 2 times tan inverse under root of tan square theta by 2. Under root of tan square theta by 2 effectively becomes tan theta by 2. Now what we have is tan inverse of tan theta by 2. So can I say it will be nothing but theta by 2? Yes. So here we write 2 times theta by 2. 2 and 2 will get cancelled. So what we get is cos theta. The entire function which was given to us, such a big function, on simplification is just as good as cos theta. Now my dear students, if you recall, we had used the substitution x is cos theta. So we can write that this is nothing but it is equal to x. Now what is equal to x, my dear students? Cos of 2 times tan inverse under root of 1 minus x upon 1 plus x effectively simplified is as good as x. That is, my integral is nothing but integral of x dx. Correct? Now in the next step, let me write that integral of x dx. And integral of x dx is known to me. It is x square by 2 plus c. So my option will be nothing but option B. So the correct answer is option B. My dear students, don't get terrified by the size of the question. It may be a simple question. Let's take one more MCQ. It's saying integral of sine raised to 8x minus cos raised to 8x upon 1 minus 2 sine square x cos square x dx. Again, if you see, the options are very small. The question is a big function, higher powers of sine. Let's see how to simplify. Now my dear students, if the answer has to be so simple, obviously there has to be some cancellations. I don't know what to do with the denominator, but I very well know what to do with the numerator. Sine raised to 8 minus cos raised to 8. I can write it as sine raised to 4 the whole square minus cos raised to 4 the whole square, which is nothing but of the form a square minus b square. Correct? And at school level we did study a square minus b square is nothing but a minus b, a plus b, where in this case a will be sine raised to 4 and b will be cos raised to 4. So let's write that in the integral. So the very first step in the simplification part will be writing the numerator as sine raised to 4 minus cos raised to 4 into sine raised to 4 plus cos raised to 4. Obviously I am not doing anything to the denominator. So the denominator is as it is. Now my dear students, sine raised to 4 minus cos raised to 4. Can I say again it is in the form of a square minus b square? So in the next step, shall I write it as sine square x minus cos square x into sine square x plus cos square x? Correct? Also, at school level we studied a raised to 4 plus b raised to 4 is nothing but a square plus b square the whole square minus 2a square b square. So let us apply that. A square in this case is nothing but sine square. So we will get sine square x plus cos square x the whole square minus 2 sine square x cos square x the whole divided by 1 minus 2 sine square x cos square x dx. Now my dear students, you will find many times you have sine square plus cos square. So let us just check that. So if this is the integral which I need to simplify, We observe first term sin square x minus cos square x, I keep it as it is. Sin square x plus cos square x, the favorite identity, it is nothing but 1. Likewise, the bracket is 1 minus 2 sin square x cos square x. Again, in the denominator we have 1 minus 2 sin square x cos square x. So can I say in the next step, shall I cancel this 1 minus 2 sin square x cos square x? Correct? So what is left for us is nothing but a very small function, sin square x minus cos square x, which is written as minus of cos square x minus sin square x, because we know a formula from standard 11, that is nothing but cos 2x. So let's write that as minus integral cos 2x. So such a big integral simplified to a small term cos 2x. Let's integrate that. That's nothing but minus 1 by 2 sin 2x plus c, and this is which option? Out of the 4, I see this is option A. So the correct answer is option A. So a very big function but a very simple integral. Okay, that's all we have in this module. Thank you very much.